Hi everyone, let's take a look at a problem now, a generic problem that's going to have to do with rigid bodies, and we're going to assume a static situation, so we're going to have equilibrium, but we're not going to only have force equilibrium, we're also going to have moment equilibrium. That is to say, the sum of the moments will equal zero, and we're going to keep things nice and simple. We're going to be in a two-dimensional situation. So here's a truck, and it's got three forces acting on it. There's a normal force on the front wheels, there's a normal force on the rear wheels, and then there's the weight. So I have a normal force due to the road acting on the truck. I have another normal force due to the road acting on the truck. The wheels are part of the truck, so I don't say on the wheels, I say on the truck. And then we have a gravitational force due to the earth acting on the truck. And everybody here is in the y direction, so I don't have an equation if I do the sum of the forces in the x equaling zero. There are no forces, so we're not going to do that because it's of no value. But I do have the sum of the forces in the y direction, and those are also going to be equal to zero because I'm in static equilibrium. So I have two upward forces, the front and the rear wheels, right? So there's a normal force at the front, and there's a normal force at the rear, and those are both in the positive direction. And then minus the weight of the truck, so minus mg, that's downward, and so those are going to equal zero, right? Those are going to equal zero. And then I've also got the sum of the moments. Now, this is actually really easy in two dimensions, in this particular problem at any rate, because there's only clockwise and counterclockwise moments. But the question then becomes sum of the moments about what point? And that's up to you as the person solving the problem to choose whatever point is easiest. I'm going to actually do this around the center of gravity, which I'm saying mg is where that's where all of the weight of the truck can be assumed to be concentrated. And so I'm going to label that g. And so I'm going to say the sum of the moments about g. And so if I look at the forces involved, remember that a moment is r cross f, but if I take my distance from g to either of these two forces, and actually it's interesting to note that it doesn't matter that there's a vector in here, right? There's the vector. I'm going to call that r front. Okay, and that's the vector r front. And so the angle between the normal force and r front is this angle in here. So I would have rf sine theta, right? But by alternate interior angles, this angle and this angle are the same. Those are the same angles. And so what do I end up with? I'm going to end up with r front times nf times the sine of that angle. And I'm going to call that angle theta. Right? So that's theta and that's theta. And then let's go to the rear. All right, so here is down to the rear tire, so I'm going to call that r rear. And there's going to be an angle in here, which is the same as the angle in here, and I'm going to call that phi. And so that's going to be r rear, the magnitude of that vector, times n rear times the sine of phi. Okay? And when I add those moments together, there's mg is at g, right? So the distance between g and g is zero. So the gravitational force does not apply a moment about point g. It could apply a moment about a different point, but it does not apply a moment about point g. All right? And so this is all going to equal zero. Notice I don't have any signs in here, right? In SIGNs, there are signs. There's a sine of theta and a sine of phi. But I want to take a look at the right-hand rule. So what do I have here? I've got r front, and then cross that with n front. So r front is this way, rotate my hands up to n front, and that's into the board, right? That's into the board, so that's negative. So I'm going to put a minus sign in here. And then if I go to r rear, and then rotate my hands to n rear, that was an upward force, right? So the right-hand rule says that's out of the board, so this is going to be positive. That's going to be positive, okay? But let's take a look at this for a second. So I have minus RF times NF, and I'm going to reverse that. And I'm going to say NF times RF sine theta. And I'm going to put RF sine theta in parentheses, plus N rear, R rear sine phi. And that's going to equal 0. But if I look at my triangles in here, and I'm going to make this bigger, so R front is there, and N front is here. That's a bad position. Let me redraw that. R front, N front, and then this is the angle theta. But R front times the sine of theta is opposite over hypotenuse. And so that's going to be this distance here. Doesn't matter that N front is a longer side. This distance right here, I have that labeled. That's R1. That's R1. Or what I've called in previous videos the perpendicular component of the radius vector to the force. You could do the perpendicular component of the force as well, but in general, in a diagram, the perpendicular distance is given, not the perpendicular component of the force. And so this is the same as, this is going to be minus N front times R1, and in a similar fashion, this is going to be N rear times R2. This will be the perpendicular distance. The sine of phi is the opposite side. So this will be N rear times R2. And that's going to be my net moment. That's going to be my net moment, right? And in this case, because this is statics, this is equal to 0. And so I have an equation here, and I have an equation here. And so when I do the sum of the moments, I'm going to generally have 3 equations and 3 unknowns. In this particular case, there's no x equation. But I'll have an x equation, I'll have a y equation, and I'll have the sum of the moments about some point. Now, here's my challenge to you. What if you decided that you want to do the sum of the moments about this point right here at the front wheel? How's that answer going to compare with the answer I get here? And I'm going to tell you that it's going to be the same. So the question becomes, well, why would I choose G and not the front of the wheel? And the answer is because it depends on what you're given. If I am given the weight of the truck and where the center of gravity is, I really want to do the sum of the moments about the front wheel or the rear wheel. Because if I do that, mg is a known, nr is the only unknown, and I'll end up, when I do my moment equation, I'll end up with only one unknown, and that would be n at the rear wheels, if I know the weight and all these distances. And so I don't have to worry about solving a system of equations. I've got one equation that's already going to be solved. There's only one unknown in that equation if I do the sum of the moments about the front wheel. Okay? So real quickly, if I do the sum of the moments about the front wheel, I'm going to get mg times r1. All right? So mg, so r times mg, that's going to be, well, or think about it, if I put a pivot here, mg is going to try to rotate the truck in the clockwise direction, and so that's going to be negative. And then nr, n at the rear, that's going to rotate the truck in the counterclockwise direction. If I just lift at the back end and there's a pivot here, it's going to rotate the truck in the counterclockwise direction. So that's going to be plus n rear times r1 plus r2. And so in many cases, the r's are given and the weight is given. N rear is the only unknown in this equation. And so I can solve this equation. all equal to 0. I can solve that equation right away and then go and substitute into the force equation, and I'm good to go. So where do you choose your moment? Wherever it makes your equations nice. If you're not sure, it doesn't matter. The mathematics might be a little more difficult at one place than another, but you'll get the same answers whether I choose the sum of the moments about G, the sum of the moments about the front wheel, or the sum of the moments about the rear wheel. It doesn't matter. You will get the right answer no matter where you choose the sum of your moments. All right? So hopefully that'll give you a little bit of a head start on some simple moments. We're going to get into more complicated moments as the semester goes on. If you have any questions, please leave them in the comments below. Thank you.